Okay. Let's discuss about the exercise that we did last week. For the, I saw your exercise. For the question, I only discuss about the question that you did wrongly. So let's us begin with the question 4. For the question 4, I think there are some problems with the question, so we just skip it because the question is quite weird, and this type of question will not be asked in an exam like this because it is confusing. So let us go to the objective questions for inertia. And for this part, yeah, the front part, for the 3A1, your answer is correct and the other are correct. That means for the inertia part, your answer for question number 1 is correct. So let's discuss about the question number 2. For question number 2, I think your answer is donkey velocity. But for this question, they ask which properties of a body resist a change in its state of rest or motion. In our last class, we talked about the inertia will only be affected by mass and velocity. That means we have two choices in this question, but which property of a body? That means it might relate to our physical quantity of our body, because of the mass is in our body. Instead of the velocity is when we run or perform any action, so the mass will become the property of a body that resists, because the mass is just inside our body and the velocity is what we perform during certain activities or running. So that there is different. So when they ask about the property of a body, that means the best answer for this question is C. And for the question 3, we also need to discuss because there are also some uncertainty in this question. The questions say that if an astronaut walks on the moon's surface, what can you say about this what can you say about his inertia? For this question, you need to compare the mass of the astronaut when they are in the when the astronaut is on the earth and on the moon, in two different situations. For the astronaut on the earth, let's say the mass to be 60 kg, and this is the mass. And will the mass of astronaut will be changed when he is on the moon? When we talk about the freeform motion, we say that only let's talk about the weight. The weight for 60 kg, that means that on the earth the gravitational acceleration is 10 meter per second. That means the is due to the gravitational acceleration. So we just times 10, then we will get 600 Newton. The weight of the person is, when we on the moon, that means the gravity on the moon is much lower. That means the weight of the astronaut will be definitely lower than 600 Newton, but the mass will be remain the same. So according to the mass will remain the same, that we can conclude that their inertia are the same, because the mass of the astronaut does not change, although they are whether he is on the Earth or he is on the Moon. The mass of the astronaut remain constant. That is 60 kg. The only thing that changed is only the weight of the astronaut. Let's say this is about 500 Newton. So that is what affecting. Let's say about if you consider that the astronaut can walk faster on the moon, that it doesn't make sense, because for the inertia it will be affected by mass and velocity. The mass will definitely be the same as we just discussed. For the velocity, actually the walking speed of the astronaut on the moon and on the Earth are actually the same one. They can walk because they can walk at the same speed, although same velocity, although the gravity is not same, because that is how they because it's only depend the velocity of a person walking is not depend on the gravity, is not related to the gravity of a planet. So that means if two property are the same for the astronaut, that means the inertia does not change. So for this question, the best answer is C. Okay, let's go to question number 4. Okay, for this question number 4, I saw you choose the answer is A. So let's have a discussion on this. A heavy truck difficult to start moving and difficult to stop. That means when the question say that the heavy truck difficult to start moving, that means the truck tend to remain at when the truck is stopped, the truck is difficult to start moving, because the truck tend to remain at its original state of motion. This is because the principle of inertia, original state of motion, which is at stationary. So the truck will be difficult to start moving, and for the truck difficult to stop, just is also because of the tendency of itself to remain, tendency of the truck to resist change made to its original of motion. Just like the situation that we discussed in our last class, when the bus stop and move and start to move, the person will drop backward, and when the bus move at a certain speed and it stops suddenly, then the person will jerk forward. There is almost the same principle with that situation. it changed to a heavy truck, difficult to move and difficult to stop only. So when we talk about the tendency of an object to resist its change due to back to its original of motion, we already think about the concept of inertia. For the concept of force equilibrium, actually the concept of force equilibrium you will learn in the in the future. The force of equilibrium is just when the one I give you one example. When we hang something, let's say a traffic light hanging on the pole. When we hang it with two ropes, the tension of this rope, let's say the A rope, and this rope B, the tension for these two ropes, the tension for these two ropes is the same. That we can and the traffic light must be at the stationary, because when we say the force are in equilibrium, is in equilibrium. When we say the force in equilibrium, that means the upward force and the downward force are the same. The force to the right and the force to the left are the same. So all the whole system will be at the stationary state and nothing will move. And in the future we need to, that means just now we say that the tension of group A and the group B are the same. So that means the force exerted on these two groups are the same. That means that what we say, then the force is in equilibrium, because two groups have the same force, and the downward, upward, right and left force are exactly the same. That is what we say that the force in equilibrium. For this, we will learn to how to calculate the tension in these two groups in the future, and I will teach you in the next time. And let's go about the next section. For this, this structure question in the part of inertia 2.4, I saw your answer. Your answer for 1A is correct, because it's just the definition of the inertia, as you I hope you already memorized it. So let's go to the 1B question. 1B, relate mass to inertia. Actually, when we talk about the relationship, the most common way to express relationship, that means relationship is we use the common formula, that is the greater the mv, the greater the rv. That means in this situation, mass will definitely become the mv, because the inertia is affected by the mass, and there is no way that inertia can become the mv, because the inertia of an object will not affect the mass. Only the mass will affect the inertia of an object. So we can say that the inertia is come from the mass. When the mass is lower, the inertia will be lower. The mass is larger. The mass is larger, then the inertia will be larger. So we just use greater. The answer is the greater the mass, the greater the inertia. That is the answer for question 1B. I saw your answer. You say that I get it. You say that the inertia, the greater the inertia, the greater the mass, the more mass in an object. That is inverse, because you should reverse the sentence. You should put the MV in front and say and talk about the RV at the back. So for your answer, I saw that is quite confusing, and people will assume that you say inertia, the greater the inertia, that means the inertia will affect the mass. So the better way of writing the relation, that is the relationship, is the greater the MV, the greater the RV. You need to identify the manipulated variable and the responding variable first before you write this sentence, and that is the best way of writing the relationship in just like in this sentence. Okay, let's move to another question. For question 2, you did it correct, and let's talk about question 3. I saw your answer. You just write airbag and safety belt. That is a good way, but you should say how a driver can reduce the negative effect. When you just say the safety belt, safety seat belt or safety belt, you doesn't it make no sense, because is what should the driver do? You only say the safety belt, just like is this question is not asking for the safety feature in a car. If this question is asked about the safety features in a car, then you can say like that: the airbag, safety belt, anti-lock braking system, pedal dashboard, and others, shatterproof windscreen, and other many type of features that protect a driver and reduce the effect of inertia. Actually, airbag and safety belt is correct, but it is not what the driver can do. When you talk about what the driver can, when we talk about what the driver can do, where we just the safety belt is correct, but you should put a verb in front of that, just like wear safety belt. That means that's what the driver can do, isn't it? And for the second one, you can say for the airbag is actually the safety feature of the car, so it's already inside the car, and the driver don't need to install by himself, except that in the case the driver buy a second-hand car and the airbag has been pulled out by somebody, and so he need to install another new one. But for the normal situation, we cannot say just the driver install the airbag, because the airbag is already inside a normal ordinary car. So we just use install some soft cushion, install some soft cushion in the car. That means soft cushion is the install some soft material at the dashboard, at the seat, and the door, if you want, just like some of the soft cushion to actually its function as almost same as the airbag because also can reduce the effect of inertia. But some of the car that don't have this feature, so you can write soft cushion, but for the airbag, for every car there is definitely we need a airbag. So for they in the company, the manufacturer of car company, just like Proton, Toyota, and BMW or Mercedes, all the other car already install a safety airbag before you buy it, because there's necessary for a car to have an airbag for any type of car. So the driver cannot install by himself. The driver only, the things that the driver can do, only install some soft cushion in a car. Okay, for the question number 4, you did it correctly. So that's all for the discussion of exercise we did in our last class.